Now, in this lecture, we discuss a few problems on rectifiers. First problem is half-wave rectifier. In this, some data is given. So, load is given as a 3.5 kilo ohm. And total diode resistance and secondary resistance together, it is a 800 ohms. And input voltage has signal is peak voltage is given directly. So, now here, if I draw the diagram is like this. So directly AC is connected to the half wave rectifier. And here the voltage is 240 volts, peak value. This is the peak value. And the frequency is not mentioned. So no need to bother about that. And the load is 3.5 kilo ohms. And the total resistance, so RL is equal to, I will take RL is equal to 3.5 kilo ohm. And secondary plus diode forward resistance, both together it has a 800 ohms. And VM, it is given it as a 240 volts. Now from this, we need to calculate the peak average RMS value of current. So for that, what IM is equal to, so we can take it as, what is the formula for IM? VM by total resistance, RS plus RF plus RL. Now just put 240 divided by 3.5 kilo plus 800. Then you will get the value 55.81 milliamp. Now, peak value over. Now let's take the average value. That is nothing but a DC. IDC is equal to IM by pi. Now this is the half wave rectifier. IM by pi. That is nothing but 55.81 milli divided by is equal to 17.77 milliamp. Now, similarly, we need to calculate the IRMS. IRMS is equal to IM by 2. This is a half-wave rectifier, IM by 2. That is nothing but 27.905 milliamp. Now, all the currents we derived. Now, DC power and AC power. So, DC power, PDC is equal to, there are three formulas are there. VDC into IDC, VDC square divided by RL, or IDC square into RL. Now in this, because in this we don't have a VDC, that's why I will take this formula IDC into RL. We have these two values. Now if you substitute 17.77 milli square into 3.5, then you will get the 1.105 watt. Similarly, PAC is equal to VRMS into IRMS, or we can, here current is there, that's why I will take IRMS square into total resistance. So secondary voltage resistance plus diode forward resistance plus total load resistance, if I calculate, then this I will get 3.348 watt. Now we have both the values. So you can calculate percentage of efficiency is equal to PDC divided by PAC. If just substitute into 100, if you put those values, so we get 33 percentage. Now this is how we need to calculate the values in the half wave rectifier. Now next, coming to the full wave center tap transformer, and the ratio is given here. So ratio is given. So center tap transformer and the secondary ratio, total secondary ratio is given. That is a 5:1. And the input voltage is 230 volts, 60 hertz. And also given, now used for full wave rectifier, load resistance is given. So this is the two diodes. And load resistance is 900 ohms. And the secondary and diode forward resistance, both together it is a 100 ohms. So RL is equal to 900, RS plus RF is equal to 100 ohms. Now from this, we need to determine the DC voltage across the load, DC current flowing through the load, DC power delivered to the load, and PIV, ripple frequency, and ripple voltage. So now here the ratio is given. Now in the transformer, to calculate the secondary voltage, now this complete voltage we are calculating by using this turns ratio. So that is V1 divided by V2, nothing but primary voltage divided by the secondary voltage is equal to primary turns divided by the secondary turns. From this, V2 is equal to, we can write it as V1 into N2 divided by N1, that is 230 divided by 5. So with this, we are getting the V2. It is complete voltage of the secondary, that is 46 volts. So this is the 46 volts from here to here. But what we need to calculate all these values, we need this and this. So how we will get that? By dividing the 2. So now if you divide the RMS, VRMS is equal to VRMS at secondary is equal to 46 volts divided by 2. That is nothing but a 23 volts. Now here 230 is the RMS voltage. So for that we are getting the RMS voltage, not the peak value. Now we need to convert this into peak value. Now here this secondary peak value we want. So for that V peak is equal to VRMS into root 2. That this is the V peak. Now from this what we need to calculate, first one, DC voltage. Now what is the formula for the DC voltage in the full wave rectifier? So VDC is equal to 2Vm by pi. So 2 into what is Vm? Vm is nothing but VRMS into root 2. So 23 into root 2 divided by pi. If you solve this, then you will get the VDC is equal to 20.7 volts. Now, after that, what we need to calculate? DC current through the load. So IDC is equal to VDC divided by total resistance. RS plus RF plus RL is equal to 20.7 divided by 900 plus 100 is nothing but a 1 kilo, that is equal to 20.7 milliamp. So this is the IDC. Now PDC is equal to, now you know the VDC and IDC, just if you multiply these two together, then you will get the PDC, or otherwise IDC square into RL. So anything if you do, then you will get. So now here you will get PDC is equal to 0.386 watt. So this is a PDC. Now next one is PIV. Peak inverse voltage in a full wave rectifier is how much? It is a 2 Vm. Now here the Vm is VRMS into root 2. So 2 into VRMS is 23 into root 2. That is nothing but 65 volts. Now this is the PIV is 60. No, sorry. Yes, PIV is 65 volts. Now next one is the ripple voltage. Ripple voltage is equal to, it is not the ripple factor, it is a ripple voltage. It is nothing but a AC RMS voltage. That is under root of VRMS square minus VDC square. Now you have a RMS value at the secondary and you have the VDC. Just you take the square of these two and subtract and take under root. Then you will get the ripple voltage is equal to 10.05 volts. Now after that, ripple frequency is nothing but, in a full wave rectifier, ripple frequency is output frequencies. It is nothing but 2 times the input frequency. Now here the ripple frequency is 60. So you will get the ripple output frequency or ripple frequency is equal to 120 hertz. Now this is the output frequency. So like this, you have to calculate. Now, if I ask you to find out the efficiency means what? Here you have a DC voltage and here AC, you need to calculate. RMS is there and you have a load and RS value, RF value. So from that you calculate the PDC and you take the ratio of PDC, PSC and take the ratio of PDC to PSC, then you can find out the efficiency also. Now here efficiency is not asked. If asked, then you have to calculate like that. Now next one is a bridge rectifier. Turns ratio is given, means what? Now input AC is connected to the transformer and the transformer turns ratio is 10:1. Secondary is 10 and primary is 10, secondary is 1 and input is connected to the 220 volts 50 hertz. So input supply ratings are this. And now here the bridge is connected to the, and find the DC output. Now here load is not given means what? It is a open. Now load is not given means no load conditions. Under no load conditions, we have to calculate. Now for this, what is the formula for the secondary? Secondary V2 is equal to V1 divided by 10. So how we got? Now in the previous lecture, I have explained the relation between the voltage to the turns ratio. From that now we get this. So this is nothing but a 220 divided by 10 is equal to 22. So this is nothing but a VRMS. So this is RMS value. So VRMS is equal to 22 volts. From this, we need to calculate the V maximum. So V maximum is equal to, how to calculate V maximum? VRMS into root 2. That is nothing but 31.12 volt. And from this, what we need to calculate, what I have asked to find out the output DC. So VDC is nothing but VDC is 2Vm by pi. So 2Vm by pi. If you calculate this, then you will get the 19.81 volt. Next one is what I have asked, PIV. Now in the case of bridge rectifier, what is PIV? It is nothing but a VM. And what is VM here? 31.12 volt. And next asked the ripple frequency is nothing but output frequency is nothing but 2 times the input frequency. Now here the input frequency is 100. So sorry, input frequency is 50. So output ripple frequency is 100 hertz. Now this is how you need to calculate the factors with the given information. Thank you.